In today's lesson, I'll show you how to find out the volume of the body after the body completely immersed into water. So if we go through this example number 1, a body weighs 3.1 Newton in air and 2.2 Newton when completely immersed into water. The density is being given is 1020 kilogram per meter cube, and he wants us to find out the volume. So before we rewrite any equation, we need to find out the weight of the displaced water. Okay, the weight of displaced water. I'm gonna call it capital W. So it's just the difference between both of them. So WW equal the weight while in the air, take away the weight when it's being merged. So we have 3.1 Newton, take away 2.2 Newton, and it will give us 0.9 Newton. Now we're gonna rewrite the formula. Okay, so we have the weight of displaced water. I'm gonna call it WW equal volume of the body multiplies by density multiplies by gravity. So let's just try to write it down as letters instead of the word. So I'm gonna write capital V instead of volume, and instead of density I'm just gonna write rho, and instead of gravity I would write G. So all I do now is just put the numbers. So the WW was 0.9, volume is unknown, we want to find out, multiplies by density, which is 1020, multiplies by gravity, which is 9.81. Okay, so basically we want to make the volume the subject. So to get rid of density and gravity, we're going to divide both sides. Okay, divide both sides by density and gravity. So we're going to end up having volume equal 0.9 over 1020 times 9.81. If we put this in our scientific calculator, the answer will be 9 times 10 to the power minus 5 meter cube. Okay, so now let's go one step further by looking at the next example. Okay, example number 2, a rectangular watertight box is 570 millimeter long, 420 millimeter wide, and 215 millimeter deep, and its weight is 235 Newton, and it floats with its side and ends vertical in water of density 1040. What depth of the box will be submerged? So basically we're going to start the same as we did before. We're going to rewrite the formula is equal volume times density times gravity. And as I show you on previous example how to rearrange this formula, we're going to end up having volume equal the weight of the water, displaced water over density and gravity. So we will have V equal, so the weight of the displaced water in this example is 235 Newton over Density is 1040 times gravity 9.81. So if you put this in our calculator, the volume will be 0.023 meter cube. So all we need to do now to find out the depth. And I'm sure you all agree with me. The volume of any cuboid or cube or rectangular box is equal length times width times depth. Okay, so I'm going to try to write down as a letter: length times width times depth. So again, if I want to rearrange this equation, if I want to make the depth the subject, I'm going to divide both sides by length width. So I'm going to end up having volume over length times width. So now I'm going to replace my numbers. So the volume was 0.023 and the width was, just double check, the width was 570 millimeters, so it's going to be 0.57 meters, yeah, 0.57 meters times the width, which is 420 millimeter, will be 0.42 meters. Put this in the calculator, will give us 0.096 meter, or if you want to convert it to millimeter, you're going to end up having 96 millimeter. Thank you.